Alright, good morning. Time for another video. Hey, it's year 2 and the James Webb Telescope is killing atheism. Interesting. So it's just over 2 years. About 2 years and a couple of months anyway. And the James Webb Telescope again is taking a wrecking ball to the old cosmic evolutionary story. So in this video I'm going to cover two different secular science video clips, but before we do, for those who haven't watched any of my previous videos, I'm just going to give a very brief overview of the what I call the old cosmic evolutionary story. And then we're going to contrast it with the recent James Webb Telescope discoveries. So without further delay, look at this picture. This is a NASA picture. Each vertical line represents 1 billion years. So over to the left, you have the beginning of the universe, the Big Bang, and in the first seconds of the Big Bang, between 10 to the minus 37 seconds and 10 to the minus 34 seconds, the universe went from a size of 0, basically, to a size, Andre Lent says, quote, much larger than the part of the universe that we are capable of seeing, and it did that in a trillionth of a trillionth of a trillionth of a second. Well, we can see 90 billion light years across. So what happened at the beginning was an inflationary period that Alan Guth and Andre Lent talk about, cosmic inflation theory. Not only do they believe that, they also believe in eternal cosmic inflation. What does that mean? Well, they believe in the multiverse, but that's a different story for a different video. Anyway, at the beginning of the universe, it went from size of 0 to much larger than the part of the universe we can see in a trillionth of a trillionth of a trillionth of a second. That's over 90 billion light years across in faster than I can say, boop. I mean, give me a break. Anyway, what does that sound like? Well, that sounds like Ain't God Said. And then they had the microwave background radiation, where you can see in the picture there the blue, the yellow, the green, etc. over at the left of the picture. And then you have basically an empty spot, which I would expect it if there was cosmic evolution. There'd be a time when there were no stars. And then you have these huge behemoth gas giants, supposedly, which they can't see, by the way. And we'll talk about that later. But then you'd have the first stars, and then you'd have infant galaxies, and then bigger galaxies. And as you can see, the galaxies are tiny in comparison to the bigger ones over to the right, to where you get to like a Milky Way galaxy, which is supposedly a mature galaxy of over 13 billion years old. All right, well, James Webb has upended all of that. So that was what we were talking about. Now, closer to the bottom, Neil deGrasse Tyson at the bottom, he says, we're stardust, we're made in the crucible of stars. Well, it takes 3 to 4 supernovae, supposedly, to build the heavier elements. 3 to 4 supernovae. And like our star is like 5 billion years old, expected to live another 5 billion years old. But at the end of it, it'll go supernova. Anyway, so it would take billions of years to get to 3 to 4 different supernovae before even biological life could show up in the universe. And again, all of that is upended now. Okay? Now, there's only one problem, like I said. It's not true. All of that's not true anymore. James Webb has changed all of that. So let's watch the first video clip.
In the last 2 years, since the James Webb Space Telescope started to release a lot of its data, quite a few discoveries have already raised a few eyebrows, with some of the most unusual discoveries so far basically being from the edge of the universe, from the location very far away from us at extremely high redshifts. And this is essentially what the James Webb is actually really good at. It's able to easily discover these very distant objects when the universe was only a few 100 million years old, and when stars and galaxies were still just forming. But one of the more unusual discoveries, and I guess one of the more controversial ones, was officially announced and officially published sometimes in early 2023, and it can be summarized with this picture right here. Now, you can actually learn the details in a few videos in the description below, but in a nutshell, it was a discovery of at least 6 different galaxies, specifically red galaxies, that seemed to be a little bit too massive and already existed in the universe 750 million years after the Big Bang. And these unusual 6 candidates had a lot of solar mass. For at least one of them, the solar mass was estimated to be 10 to the power of 10 or even a little bit higher. And that means that there were 100 billion solar masses in these early galaxies. Our galaxy, the Milky Way, is only believed to contain 60 billion solar masses. And our galaxy took approximately 13 billion years to develop. And so something here was not adding up. And almost right away, we had quite a lot of controversial claims that maybe the universe was actually much older, or maybe the Big Bang theory was completely wrong, or maybe these were not galaxies. And we've actually addressed quite a lot of these claims before, but just to give you a short version of all of this, back then none of this violated the Big Bang or even most cosmological theories, but did potentially present a small problem for how we believe galaxies form, which might have resulted in rapid formation of ancient stars. And though once again this doesn't break cosmological models, it breaks the models for galactic formation and the growth of supermassive black holes. It was always believed that black holes and galaxies more or less grow together, but these observations suggest that this is not the case. Black holes potentially controlled everything early on and possibly forced a lot of galaxies to grow around them, which included stars forming very early and very rapidly in an extremely active dynamic environment that we just don't understand. And here the spectral analysis pretty much confirms that these are galaxies with black holes and star formation, unlikely to be unusual exotic objects or something else that was claimed previously. But the actual properties don't make sense. The black hole is way too large, the stars are a little bit too old, and all this can only be explained if these galaxies formed super fast. But that's actually the explanation that a lot of scientists are now leaning toward. Something in the early universe forced everything to basically produce a lot of stars quite rapidly, and that something could have been the existence of these very massive black holes that were essentially all over the place. But there's actually something else that's very surprising here, and it's basically the mass combined with the size, which really does not make sense at all, or at least it doesn't make sense for now. And once again confirms that whatever happened here happened super fast, extremely suddenly, and using phenomena and mechanisms we don't understand. There is currently no explanation and no model that can easily explain the formation of these bizarre objects. The focus is going to be on the absorption signatures, just to see what kind of elements they contain, and to discover the details of the activity within them. But I guess until those future studies and those future observations, at least 3 of these objects from the previous 6 still seem to be kind of mysterious and somewhat difficult.
We're talking about 6 massive galaxies and 750 million years after the Big Bang. So it's kind of interesting. They say 750 million years, and before it was between, well, here in the article, I have a quote from the article, between 5 and 700. Well, they're trying to push it out as far as they can, and I understand why, but these galaxies are in tension with 99% of the models of cosmology. They shouldn't have had time to form. They're dubbed universe breakers. And I've covered it before in earlier videos, and I'll leave links in the description below. But having these galaxies with that many stars in the early universe based on the old story basically is a miracle. So just a clue. How could they show up so quickly? How could those massive galaxies show up so quickly? And God said. And one of the examples that the presenter Anton related was one of them has estimated 100 billion solar masses. Well, the Milky Way, which is again supposed to be a mature galaxy that developed over billions of years, has only 60 billion solar masses. So say what? What's wrong with that picture? Well, there's a lot wrong with that picture. So the presenter says that this presents a small problem. Well, I'm sorry, I disagree. It's not a small problem. Now, he does say that the Big Bang, there was still a Big Bang, there was still a start to the universe, okay, but it breaks the models for galactic formation, how they formed, and how supermassive black holes formed. In fact, what they're saying now, and they're flipping the science, they're saying, well, the black holes already existed. It was already believed that in the old story was that the galaxies and the black holes would grow together. You have to have material to feed the black hole, and as you feed the black hole and you get more and more material and more stars and more gas, etc., that's how the black holes would grow. But now they're saying no, the black holes controlled everything early on. In other words, when the Big Bang occurred, they're saying there must have already been black holes. What's wrong with this picture? And then they were trying to come up with a reason why maybe these 6 galaxies, maybe they're some type of exotic objects. But then spectral analysis shows no, they're galaxies with black holes and with star formations. So the actual properties don't make sense. The black holes are way too large. How could they form so fast? The stars seem too old, but suggests that these galaxies form super fast. I don't know what's the scientific explanation for super, super fast, but anyway, we'll go with it. But that's the explanation that the scientists are leaning on. It happened too fast, super, super fast, whatever. So something in the earlier universe, the presenter says, forced everything in the universe to produce a lot of stars quite rapidly. Yeah, sure it did. And God said, not only stars, but universes as well. I mean, galaxies as well. And that something could be the existence of these very massive black holes. So excuse me, how could the early universe already have supermassive black holes when it takes massive amounts of material to create them? And then another surprise from the presenter, the mass combined with the size, which really does not make sense at all, he says, for now. It just shows that what happened here happened super fast, extremely, suddenly, using phenomena and mechanisms we don't understand. So there's no explanation and no model can explain it. Naturalism is dead, period. But last but not least, the absorption lines. The absorption lines look at what's inside these galaxies, what elements are inside the galaxies. And you already have heavy elements in them. There's something extremely wrong with this picture from a purely naturalistic explanation, but not if and God said. I would expect, if it's and God said, what popped out of the Big Bang was not just hydrogen and helium. And over time, they created the stars, and over time, they created infant galaxies, and over time, they created mature galaxies. That is the cosmic evolutionary story. But if it's truly and God said, what would I expect? Well, I would expect black holes from the very beginning. I would expect stars and galaxies from the beginning. In fact, I would expect if you look out into the universe, into the past, if you're looking out into the universe, you're looking into the past, and as you look into the past and you see fully formed galaxies, in fact, you see galaxies bigger than the one you live in already, and the one you live in is supposedly 13.6 billion years old, and they're supposedly brand spanking new in comparison. I would expect there not to be, there should be, at a point in the past, no stars. And again, even according to Anton in one of my previous videos, the James Webb Telescope was designed to see within 50 million years of the Big Bang. Now there's a big problem. We see galaxies. We see galaxies with 100 billion solar masses, and ours only has 60 billion solar masses. What's wrong with this picture? Well, from a naturalistic perspective, there's a huge problem. But from a theistic perspective, and God said. So, galaxies with 100 billion solar masses compared to the supposed mature galaxy, the Milky Way, 60 billion solar masses. Well, it calls into question everything we thought we knew about cosmic evolution. There is no cosmic evolution. Even the age of the universe is up for grabs. And just because we can see, and here's the thing, if the universe can show up in a trillionth of a trillionth of a trillionth of a second, and what popped out of it was black holes and everything else, then we don't know what the age of the universe is. We don't know that our side of the universe, our location in the universe, is any older than the one on the other side. We have no idea. So he says that galactic formation and supermassive black holes. Well, galactic formation on overdrive. And how do you build supermassive black holes without materials? How do you do that? How does it just show up? So the actual, factual, scientific observation, the spectral analysis, shows that these universe breakers are actual, factual galaxies with supermassive black holes and star formation. And somehow these galaxies formed way too fast. So, and God said right back to the dawn of time. Now, the next video, we're going to talk about quasars at the dawn of time. It's another unexplainable phenomenon. So let's watch the video.
And today we're going to discuss another mystery coming out of James Webb Space Telescope in regards to the ancient universe. And in this case, it's the observations of mysterious objects known as quasars that in this case reveals something astronomers really didn't expect. Something about this one quasar here basically creates another mystery. Because first, let's actually discuss this quasar investigated by the James Webb. It was actually discovered kind of by accident using an infrared survey that was technically looking for a lot of different brown dwarfs and maybe some distant galaxies. But in 2011, an unusual red spot was discovered here as well, which when analyzed revealed to be a distant quasar at a redshift of more than 7, which basically implied that this object existed when the universe was only about 780 million years old, with this object basically being about 29 billion light years away from us. And so because this object was actually emitting a lot of UV light, it was eventually redshifted into infrared frequencies. And that's why it was not just visible, but was also extremely bright. This was a powerful quasar emitting huge amounts of energy. And back then, in 2011, this was the most distant such object. Although approximately 10 years later, researchers actually found another one slightly farther away. But because it was so bright and because it was so far away, it basically suggested that this was also an extremely massive object. It was actually producing approximately 63 trillion solar luminosities, which suggested that the black hole here was possibly approximately 2 billion solar masses. And because this was early universe, this already created a bit of a mystery. How exactly would such an object form? And more importantly, how could such a massive black hole form? Interestingly, this was also one of the few quasars detected during the reionization period, or essentially when the universe was still not truly transparent. What was strange about this observation was really the size of the black hole. Its mass suggested that this black hole could not grow to these sizes by feeding normally. Even if it was able to feed at its maximum speed, the so-called Eddington limit, it would not grow to 2 billion solar masses in such a short time. And so this actually suggested one thing. This black hole was already born massive right after the Big Bang. The unexpected discovery is that there seems to be nothing unusual about this quasar. It's not actually feeding faster than other quasars, and as a matter of fact, it seems to resemble every quasar we've seen so far in every part of the universe to date. And that by itself is already kind of unexpected. Since all of the properties produced by this quasar are pretty much the same as other quasars, and since this quasar basically seems absolutely normal, no matter what wavelengths researchers looked at, it implies that all quasars seem to grow in the same way, they seem to have very similar feeding mechanics, and more importantly, they seem to have already matured when the universe was only 780 million years old. Definitely a super intriguing discovery and a really intriguing observation of a super distant quasar that technically shouldn't even exist. Yet it clearly does, and it seems to be just like every other quasar pretty much everywhere else in the universe. But at least for now, that's all I want.
Okay. Definition: a quasar is not a star, but rather the extremely luminous core of a distant galaxy produced by a supermassive black hole actively feeding on surrounding matter, emitting vast amounts of energy across the electromagnetic spectrum. Essentially, a quasar is a highly active galactic nucleus. Now look, as it said, it's a supermassive black hole doing what? Feeding on the surrounding matter. That's correct. And that's how it gets its energy, and that's how it shoots its energy out into space. So, from the video, a quasar, this one supposedly is 780 million years old, and it's a powerful quasar emitting huge amounts of energy already, and suggests this is an extremely massive object, 63 trillion solar luminosity. And the black hole at the center of it is 2 billion solar masses already. So how could such an object and black hole form so early? Again, they don't know. It formed during the time when the universe was not truly transparent. That's area that they call the Dark Ages. It's after the 380,000 years after the Big Bang. 380,000 years, you have the microwave background radiation, etc. And anyway, they're saying that it developed during when the universe was not truly transparent. You have to ask yourself, how? How could it possibly be there? So the presenter even says that the massive black hole at the center of the quasar couldn't grow to this size by feeding normally, even at the maximum speed. And God said. In fact, we'll see in a minute. Hopefully you'll be surprised. It's called the Eddington limit, and the one in yellow. The Eddington limit is also a theoretical limit on the rate at which a black hole can feed. It can only feed so fast. So the presenter says the quasar in question would not grow to 2 billion solar masses in such a short period of time. And it suggests one thing. This object was already born massive right after the Big Bang. So we have black holes born right after the Big Bang. Quasars born right after the Big Bang. Well, what else could be born right after the Big Bang? And when we look at the evidence from the James Webb Telescope, we see universe breakers, and one is 100 billion solar masses. And God said, can you say wow? Scientists have been trying to explain this particular quasar. It may be unusual, it may be exotic like they did before. But however, as the presenter noted, there seems to be nothing unusual about the quasar. It's not feeding faster than other quasars. As a matter of fact, it seems to represent every other quasar we have seen so far in every part of the universe. Wow. And then it has to go. You can't have non-exotic quasars at the beginning of the universe, but have exotic star formation and exotic galaxy formation, but the quasars looks exactly the same. There's something wrong with this. Number 4, he says, since all the properties produced by this quasar is pretty much the same as other quasars, this quasar seems absolutely linear. No matter what wavelengths the researchers look at, it is all normal. So all quasars seem to grow in the same way and have the same feeding mechanisms. So more importantly, they've already matured by 780 million years old. That's crazy. The quasar, quote, technically should not exist, yet it does. And it seems like every other quasar pretty much everywhere in the universe. It's not exotic. It's not exotic. Now, the Dark Ages. The Dark Ages was between the microwave background radiation and the first stars are forming. Okay? The question is, how long did the Dark Ages last? And this is a conundrum. Watch this. So here's a picture, and in the picture, in the middle, a little bit to the right, in the area where it says cosmic microwave background radiation, where the yellow line is, the pointing yellow line, it says above that, earliest time visible with light. So right after the cosmic background radiation, light was visible. Maybe it wasn't totally transparent, like he said earlier, but it is visible after the microwave background radiation period. And you get the Dark Ages because there are no stars. Now that's what they used to teach. Okay, here's the old story. Here's a quote. However, pretty quickly after this, the universe faded to black, as all of the free electrons and protons were used up and clicked together to form the hydrogen atoms. There was less and less light and less heat. Over the next billion years, get that, the universe faded from 4,000 degrees Celsius to roughly a negative 200 degrees Celsius. We have finally got a familiar black space. Okay. Remember that, 400 degrees Celsius to a negative 200 degrees, and over a billion years. Now listen, here it says this. There are still no structures in the universe. There are no stars, no galaxies, no nebula. That is the old story. Now look at this picture, and look back over to the left, look before the stars, and then look underneath where it says the first stars, about 400 million years. They've changed it. Not a billion, not a billion and a half, even though the lines show you a billion and a half still. They haven't changed that. They says, no, now stars showed up at 400 million years. Okay. And I've read anywhere from, before the James Webb, it was anywhere from a billion to 2 billion years before the first stars showed up. They had plenty of time then. Now they don't have that much time, okay? So they're changing the science again. So here's another neat conundrum. Remember it said 4,000 degrees Celsius down to a negative 200 degrees Celsius. Well, as the universe cooled way back then, right, there was something called the habitable epoch. As the universe was cooling, there was roughly 6.6 million years where it was between 0 and 20 degrees Celsius. That means humans would have been able to walk around, and some of their researchers said there was sufficient density for a single star. So, hey, we could have had life way back then. Anyway, but here's the other thing. It says, and it took more than 3 billion years for us to evolve on Earth. What? Yeah. He's talking, there's a 6.6 million years where it would have been habitable, but it takes 3 billion years for us to evolve on Earth. There's something wrong with this picture. And all of this has thrown a big, huge wrench in biological evolution. There's not enough time for biological evolution to occur. If 3 to 4 supernovae are still needed to build the heavier elements, they have to be happening in millions of years, not billions of years. And every time the star goes supernova, it obliterates everything that's in the solar system practically. There's no way that life can form. And it has to have 3 to 4 supernovae there's no way that it can form. And there's no evidence that our galaxy, our solar system, our sun is the age that they say it is. That is not a viable option anymore. The article describes the dark ages of the universe, that it lasted 1 billion years. But of course, the NASA picture changed it to 400 million years. The vertical lines still tell a different story, but I don't care. They're changing it. That's fine. Each line is supposed to represent 1 billion years of that picture I showed you. And, well, according to the picture, the dark ages lasted 1.5 billion years. And like I said, I've seen it. I've read it, at 2 billion years. Well, the real point is the changing narrative. Why? Well, because it has to change now, and I get it. So, in fact, supermassive black holes apparently arrived at the Big Bang. Naturalistic nonsense. And God said, in fact, not only did they say the black holes arrived, quasars arrived. Well, why couldn't stars and galaxies arrive? I mean, a quasar, again, has a supermassive black hole. Why can't other galaxies then arrive? And then again, when you look at the James Webb Telescope, what do they show you? Supermassive galaxies back to the dawn of time. So, galaxies with 100 billion solar masses, larger than the Milky Way of 60 billion. Okay? And a quasar, supposed to be 780 million years after the Big Bang, but also inside the dark ages, which NASA now says is only 400 million years. So nothing is adding up. Nothing is adding up anymore. And in every case, we don't understand, according to the presenter, the mechanisms that cause these objects to form. And in every case, these cosmological structures extremely rapidly developed. In fact, they said they developed when the Big Bang occurred. Well, guess what story fits that best? And God said. The quasar, in the video, it looks like every other quasar in the known universe. And it's not showing signs of overdrive, which is an actual factual evidence. There was no overdrive in the early universe. And instead, it looks like the quasar appeared with the Big Bang. And God said. And when we look out in the universe, it appears that galaxies appeared. It appears that stars appeared automatically, just like the Bible describes. Enough said. Have a blessed day. Bye.